Now we're going to add and subtract fractions and even mixed numbers. Adding is a little less annoying than subtracting, but not much. Mixed numbers are slightly harder than fractions because they're not sitting there with just the numerator and denominator. They also have a whole part out in front. And we'll deal with that as we come to it. But the keys that we need to have when we're combining fractions, right, which is adding or subtracting, and the rules are the same, except that when you're subtracting, you're adding a negative value in your numerator, and then we can deal with it from there. So we don't have to learn a separate rule for subtracting and adding. When we're combining fractions, we have to make sure that they are able to be combined, and combining fractions means they have to be the same denomination, which is a term that comes from coins. Nickels are worth 5 cents, dimes are worth 10 cents, quarters are worth 25 cents. Those are their denominations. Sounds a lot like denominator. You're not really allowed to add, say, nickels, dimes, and quarters all together and just come up with something. Maybe if you go into the decimals you can at times, but we're totally looking here to do this with fractions. So we're going to force ourselves to deal with a common denominator, which means we're going to have to get a common denomination to get this stuff done. So we're going to work with some coins to have us do that. So when we're going to combine fractions, we're going to, number one, use, which is after we find or keep the LCD as the common denominator. I know a lot of people hate that and get psyched out by it for all of our fractions. But with the concept being we need everything to have the same denomination, we need to all be the same kind of fraction, which the denominator tells you, then we'll be able to use the numerators to see how many each of those fractions is saying we have of those pieces, which are of that denominator. So we have to get a matching denominator. Then we're going to do number two. So we're in the concept of finding the LCD if it's not already there. If it's there, we'll keep it. So to do that, we're going to deal with the multiplier. For each fraction. Now the multiplier is going to have to be multiplying it by something that's worth 1, but it's going to be a specific multiplier that gets us to the common denominator. So we're going to multiply, sometimes by 2 over 2, 5 over 5, 7 over 7. We're going to get to the common denominator. Knowing what it is, we're going to almost get there right away. We're going to find out how did we get that common denominator to fit with this fraction, something called equivalent fractions, so that we have addable or subtractable fractions. So how? We're going to divide the target by what the old denominator was. The target is our LCD. What the old denominator was. That gets us the multiplier, right? We deal with a multiplier for each fraction. The top and bottom of that fraction multiplier are going to be the same, so we don't change the value. The decimal value of our fraction will stay the same. If we triple the top, triple the bottom, what that fraction holds is the same decimal. We do 10 times the top and 10 times the bottom, it holds. It's going to find the exact number to get us to the matching denominators, because we're going to have a target of the LCD. We're going to divide by what the old denominator was and see what got us here. What was the multiplier that made the bottoms work out to be even? And each fraction is going to have to take its own number that we find and multiply the top to create equivalent fractions. We do not reduce those fractions back to where they started. We actually want them to be unreduced fractions so that the denominators will match. So we're going to use that number on the bottom, and that's so we can match. Right, we're going to match the LCD, which we have to do. Use that number. On the top to balance. we have to make a match of the LCD. We have to make a balance to keep the value of our fraction. So we actually take care of the denominator first, knowing where it's going, and then we go back to the top to bring it up to balance and mean what it started to have. Then, 3, combine the numerators. Add or subtract as needed in the numerator, which is the top. And the most important 3 words in adding fractions are these. Keep the denominator. The denominator tells you what kind of fraction you have, and having them match means they're all the same kind of fraction. That's what allows you to combine the denominators. You don't add up the denominators, you don't subtract the denominators. You want to get them to stay what they are, defining your fraction. So that is the key. If you forget to do this and you reach the point where it's time to keep the denominator and they don't match, you did something wrong, or you forgot to do something, which is in itself wrong, then you can't keep the denominator. So this has to happen. It's not like, oh, I guess it just didn't work this time. This must happen. If they match, you can keep them the way they are. If they don't match, you do this work to get them to match, and then you keep the denominator, which tells you what kind of fraction you have. And then reduce. Now reducing your answer might be because it's no longer having a positive fraction in the fraction part, so you might have to do some subtraction there. Or they might have too big of a fraction, it'll have an improper fraction behind the integer part. So we're going to be having to reduce that as we come across it. Now, I want to show this with some coins. They are so dirty. Oh, don't throw money away. All these are only a nickel, but still, money's money. All right. I'm going to grab 2 quarters and 5 dimes. Okay. 2 quarters, 50 cents. 5 dimes, 50 cents. It's $1. But they didn't become a paper dollar when I did that. There I have 50 cents in quarters and 50 cents in dimes. If I make them into 50 cents, 0.50, 0.50, add them, I get the dollar. What's going on with the fractions? Well, here's what's happening. I've got my 2 quarters, and I want to show you how this works. I've got 2 quarters. 2 is what I have of them. 4 make $1. Plus, I have 5 where 10 make $1. 5 of these coins where 10 make $1. That's 5 dimes. If you reduce the fractions, you get half plus half. If you add the 1s and keep the 2, you get 2 over 2. 2 over 2 tells you it's worth $1. We're not doing that because we're going to stick with this plan that will work for anything. So what we're going to do is we're going to have to find the lowest common denominator, which is the smallest number they both go into. 10 will get me there faster than 4. I can go 4, 8, 12 and try to get there. It'll get there eventually. If I use my 10s, it'll get me there faster. Does 10 divide by 4? This is how we get our LCD. You can use the prime factorization, factor tree, and all that, but here's what we're going to do. Does 10 divide by 4 evenly? The answer is no. So you give me 10 more, which gets me to 20. 20 divided by 4 gets me 5. Okay, that means that 20 is going to be my LCD. So what I'm going to do is I'm going to put the 20 in the position of each of my 2 denominators. There's my first fraction with the 20 below, and the second fraction with the 20 below. It looks a little empty though. It only tells me that it's got a 20 in the denominator. Let's look at why. We can't just take this 2 and say, oh, now I got 2 of these things where 20 make $1. I had 2 when 4 made $1. Now I got this new thing where 20 make $1. I'll ask you a question. 20 of a certain coin is worth $1. You need 20 of these to get to $1. It's not a dime, you need 10 dimes. Turns out we need 20 nickels. Well, let's see what's going to happen here. This says, divide the target by what the old denominator was. The target is a 20. So we'll take our 20 and divide by 4. So I'm doing the first fraction only. 20 is what I've got to get to. I know it'll work when I divide it by 4. And 20 divided by 4 gets me 5. That's the number that I'm going to use. 4 times 5 on the bottom gets me to match my 20. 2 times 5 on the top is going to keep the balance of this being worth 50 cents. What does that become? Well, let's go see. That became 10 coins that are each, well, that when I have 20 of them gets me $1. So I'm going to take my 2 quarters and I'm going to exchange them for something else. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to exchange my 2 quarters for 10 of these. Those are nickels. Here's 5 nickels for the first quarter. Here's 5 nickels for the second quarter. Look at the 5 right there. That's what happens is I will give you 5 of these for your quarter each time. That's why we do multiplying by 5, so it needs 20 of these things to make $1. And I'm not going to keep it as 2 nickels. You got to give me 10 nickels. You got to give me 5 for the first quarter, 5 for the second. And the 5 that we have in red is what we use to get ourselves to match the 20 and to balance so we're still worth what 2 quarters were. And we got the 20 on the bottom. So we got this. I put that over here and I made an exchange of 10 nickels for my 2 quarters. As you may recall, I had 5 dimes. We may know that that's worth 50 cents. But now this has to go to be dealing with the 20 that it's got to have for its denominator. So we take the 20, and here we're going to divide by the old 10. This is the second fraction that we're only working on now. 20 divided by 10 is going to get me 2. So that tells me that if I do 10 times 2, I will match that 20. And if I do my old 5 times 2, I'll get a 10. Right there. How's that going to work? Each time I give you a dime, you got to give me 2 nickels. So now there's a dime for 10 cents in nickels. Here's another dime. Give me 2 nickels. Here's another single dime. Give me 2 more nickels. Right now I've given up 3 dimes to get 6 nickels. Give up another dime. Give me 2 more nickels. 4 dimes gone. 8 nickels in. Give up 1 more dime. And now that has also become 50 cents. But how did that happen? Instead of doing it quarter by quarter, there's my first dime, my second dime, my third dime, my fourth dime, my fifth dime. 2 nickels for each. There's the 2. The red 2 was my multiplier. As you'll notice, the red 2 is what was going to take me from a 10 that was too small to the 20 that I knew I needed so they could match. They can't match any lower than 20, so that means that their lowest common multiple of denominators, their lowest common denominator, happens to be 20. So now I take my 20 and I'm allowed to keep it. I have to keep it because that tells me that everything's nickels. And I say, let me have the 10 nickels from the quarters and the 10 nickels from the dimes, and let me smear them together. How many coins are in this hand? Well, not that I drop. Okay, now that the drop is resolved, there are 20. What kind of coins are they? Did they become, because I started with quarters and dimes, did they become quimes or lorders? No, they're nickels. All 20 are there. They're all nickels because they have that common denominator. Now that makes $1. And so that same process is what we need to go through every time we're here adding fractions. We need to find the common denominator. That in itself can be annoying for people, all right? Some people don't know how to do it or they're just learning to do it. There's a huge difference between that. Okay, a 2-year-old doesn't know how to do it, but by the time they're 20, they may, right? But there comes time where you got to put in the work to find the LCD. That itself is work, okay? The next thing is finding that red number that's going to get each one of my fractions to have the right denominator. and then using that red number, fraction by fraction, to keep the balance of the, let's call it the decimal value of whatever fraction we started with. Then we're in position to keep the denominator. Let's see what the numerator is, and then we'll resolve it by simplifying the fraction. So here's how we go. 1 over 8 plus 3 over 8. Okay, they're both 8s. No need to find a common denominator. Let's just get to adding the 1 plus the 3, and that's going to get us 4 over 8. That's not done until we fully reduce it. We recognize that the smaller number is 4. Does 4 divide into 8? It does. So you take our 8 and we divide that by 4. That's going to make me get 2. So we're going to take the 4 and divide that by 4. I'm going to take the 8 and divide that by 4 to get ourselves down to 1/2. We didn't need to do a factor tree to do this, but we did need to find the LCD to get it done for a single fraction, and the GCF was eventually going to be used up to help us get our common denominator. Sorry, to help us get our reduced fraction. We get our common denominator from the LCD of the denominators, we get our single fraction, and then we reduce that fraction as much as it possibly can. 5 twelfths plus 7 twelfths plus 3 twelfths. 3 twelfths is a quarter, but we don't want to reduce to that. We want the 12s to stay that way. So we keep the denominator, even though there are 3 numerators, we can go 5 plus 7 plus 3. This is 12 plus 3 for 15 over 12. We have a single fraction. Now we need to reduce that. 12 is smaller, 15 doesn't divide by 12, 15 doesn't divide by 6, 4 doesn't work. These are all the things that I'm trying. 50 divided by 12, no. 15 divided by 6, no. 15 divided by 4, no. 15 divided by 3 works by getting me a 5. So I'm going to come through here and divide by 3. And that's going to get me a 5 over 4, which is acceptable in Connect Math, but you might turn that into 1 1/4 because it's been beaten into us for so many years. Don't leave it in an improper fraction form. Well, that's okay. 5 over 4 is good. It's also 1 1/4. We'll see that in a minute. Where am I getting these numbers? In case you've forgotten. Once I have my 15 over 12, I take 12, which is the smallest of the two numbers, and I say 12 divides by 1 and 12. 12 divides by 2 with a 6. 12 divides by 3 with a 4. And then I go like this. I go 12, 6, 4. I go from smallest to biggest. And then 3, 2, and 1. And these are the numbers that 12 divides by. I start with the biggest and I try and divide into 15 until I get a hit. The first hit happened when I got the 3. 3 is not my number that I wind up with, but 3 is the number that gets me to where I have to be. If you take your 5 divided by 4, there's a full 4 in the 5. Subtract. You got 1 left as your remainder out of 4 that would take you to a new full cycle, 1 1/4. 5 over 4 or 1 1/4. So you can play this slower, you can rewind and stuff like that, but there are things going on to make these fractions work for reduction. Because now I want to take 1/6 plus 7/9. And we need a common denominator for 6 and 9. And it's not the 6 or the 9. 9 gets there faster. 9 divided by 6 doesn't work. 9 more gets me to 18, which does divide by 6, so I want 18s here. That is my lowest common denominator, the lowest common multiple of my denominators. Now, what I have to do is take my 18 and divide it by what I used to have. 6 gives me a 3. That means that 6 times this 3 will get me to 18. 1 times the same kind of 3 will get me the value of my fraction written with the proper 18 in the denominator. So 6 times the 3 I just found gets me to the 18. I knew that would work. 1 times 3 takes me to a new place where I got a 3. I got this other 18. And I know this division is going to work. 18 divided by 9. 18 divided by 9 is a 2. That means 18 is created. If I take my 9 and multiply it by 2, it surely gets me the 18. And I take that same 2 and multiply my old 7 up top, and I get 14. You can see what happens if you don't know your times tables. You know, if you don't have the core understanding of what's going on, it's really going to leave you in a tough spot. But I keep the 18, I write that first, even though it's on the bottom, and I go 3 plus 14, that's 17 out of 18. 17 smaller, it's a prime number. 18 doesn't divide evenly by 17, and dividing by 1 doesn't help. We're done. It's 17 over 18. We tried. We didn't try and fail. We tried and it wasn't possible to reduce the 17 over 18. So let's go to 5/6 minus 1/6. We're going to have 6's in the denominator, so we don't have to say, oh, they both divide by 6, multiply both by 1. If they match, and that was offered by our rules, if they already match, leave them as the 6's. We make it one big fraction. I go plus, right? I turn this into 5 plus negative 1. You know, you can certainly leave it as 5 minus 1, but that's going to subtract for 4, strong on the positive, 4 over 6. Smaller one is 4. 4 divides by 4, 2, and 1. 6 doesn't divide by 4, 6 divides by 2. 4 divided by 2 for sure. 6 divided by 2 gets me 2/3. Reduced fraction. So if you have the common denominator to start, you work with that denominator as it already stands. If you don't have the common denominator, then you have to find the smallest number that both denominators, or if you have more than 2 denominators, that all denominators go into. When you're looking for a big number, use big numbers to get there. When you're looking for a small number, use small numbers to get there. That's how I know how to get the LCD and how to find the GCF. The number to make me get a bigger number in those denominators, let me use the big number to see which one works. When I want to reduce my fraction, let me use the smallest one to see how big a number I can use for reduction. 7 over 8 minus 5 over 16. Bigger number is 16. Does 16 divide by 8? Turns out yes, it's 2. Which means that when I go here, I'm going to leave the 16 alone, and this one started as an 8. It's not going to stay an 8, right? I'm going to take the first one, the 16 that I want to be here, divide by 8 makes me get a 2. So I'm going to use a 2 on the 8 to get my 16. I'm going to use a 2 on the 7 to create a new 14. 14 over 16 is the same value as 7 over 8. But having a 16 in the denominator allows me to do the step that follows. Now, there's a number that works, okay? 0 and 1 have equal rights in my classroom. Let's watch what happens. 16 is good. You don't say, so just leave it. You said just, and that means you don't necessarily know why you do that. I want you to. 16 divided by 16 means I need a 1. And so as I come through here, 16 times 1, of course, gets me to 16. 5 times 1 also stays as the 5. I've also taken and made it into plus negative 5. So anyway, that if there's several numbers in a row, I can handle positives and negatives. But here we have 16 in the denominator. 14 minus 5, the old-fashioned way, gets you 9. Strong on the positive, 9 over 16. 9 divides by 1 and 9 and 3, which is 9, then 3, then 1. 16 doesn't divide by 9. 16 doesn't divide by 3. 16 does divide by 1, but there's no point to that, so this is finished. And this is the process that we're going through. We have to find the LCD if it's not already there. In so doing, we find the numbers that make it so that the fractions hold their values as what are called equivalent fractions. And yet they have the matching denominators that allow us to proceed and combine fractions. So 9 over 13 minus 10 over 39. Thirty-nine is bigger. So we're going to see if 39 is going to work for us. 39, does that divide by 13? It turns out it does. Long division might be necessary, but when I go after it, you see 3 divided by 1. I'm going to try a 1. No, I'm sorry. In the 10, I'm going to try can't do 3 divided by 13 is too small. 39 means I can start above the 9. I think maybe 3 divided by 1 will work for me, so I'll try the 3. 3 times 3 is 9, 3 times 1 is 3, and it works perfectly. So what I want to do is have 39 in there. I want to have 39 here, and I have 39 here. I'll turn this into plus and negative, so I'm ready to deal with those denominators and numerators all as we come across them. So 13 divided by, so we need to get to 39, right? We're dividing by our old 13, and that's where that 3 comes right back to us. 13 times 3 will make the 39. 9 times 3 will balance it with 27 over the old 30. 27 is new over the 39. We got a 39. You may know for sure that if it's already 39, it does stay as 39. But what we're doing is taking the 39 we have, divide by 39, the number it makes is 1. That's why also the 10 stays. I have moved it to plus negative, so I've got plus negative 10, but it's the same as 27 minus 10. Gets me 17, that's a prime number over 39, so the only thing to try is, does 39 divide evenly by 17? Because 17 only divides by 1, and 17 is useless for this, and it doesn't. That makes that done. But what we're going to have in the homework and quizzes and so forth are some of the problems will have reducible fractions when you're done, after you've made a single fraction. Others will require you to leave it the way it is, and sometimes we'll have to deal with mixed numbers, or we'll have an improper fraction after we've done our adding and we have to reduce the number that way. So that's what we're going to look at now. What we're going to deal with here is mixed numbers. I want to tell you while I'm erasing what a lot of teachers have you do, and it's too much work. It's work that doesn't need to be done because we can handle adding integers. Some teachers have you make each number into an improper fraction, and then that makes for a big numerator, and then you got to get the LCD, and then that makes for an even bigger numerator in many cases, and then you got to combine and reduce these large numerators. We don't need to do that. Okay, we have to go through the process of dealing with whole numbers as well as fractions. If the fraction needs to borrow a whole number, it gets a little challenging. If the fraction goes above 1, it creates 1 and something for the mixed number that it makes, and we can deal with that. So here's what we're going to do. If there are whole numbers, or if there are mixed numbers, what we do is, number 1, combine the fractions. Two, combine the whole numbers, right? Like integers you want to call them, because some will be negative. Simplify the fraction by borrowing or creating a 1. From whom? From the whole number. If you don't have enough, you borrow 1. If you have too much, you create a 1. And you're going to have just a proper fraction at the end of your mixed number work. But remember, if you don't have enough, borrow 1. If you have too much, create a 1 to get yourself down to a proper fraction at the end of this mess. Let's look at 2 and 5/9 plus 7 and 1/3. Here's how this can really go. This is 4 things. It's 2, and it's 5/9, and it's 7, and it's 1/3. So 2 and 7 is done as a 9. The whole numbers are done. This we have to deal with. So I'm going to go with what we've been doing. 9 and 3, 9 is bigger. Does 9 divide by 3? It does. So they're both going to have 9s. The 9 we need divided by the 9 we had leaves it alone. Great. That means that we still have 5 over 9, and that's ready to go. Second fraction of the fractions. 9 divided by 3 gets me a 3, top and bottom. 3 times 3 makes the 9 we must have. 1 times 3 keeps the matching value of what 1/3 was. The 9 is in front. Back here we got 5 and 3 for 8 over 9. Doesn't reduce, we got 9 and 8 ninths. And that's done. There's no need to turn them into improper fractions. If there's a need, we do it at the end, creating a 1 if we have extra, borrowing a 1 if we are short. That's what we need. 3 and 2 sevenths. Plus 4 and 3 fifths. We have 3, and we have 2 sevenths, and we have 4, and we have 3 fifths. So what we have 3, and we have 2 sevenths, and we have 4, and we have 3 fifths. 3 and 4 make 7. It's the whole numbers. This we got to deal with. So 7 is the biggest. 7 doesn't divide by 5. We'll recognize something that divides by 5 when it ends in a 0 or 5. 7, 14, 21, 28, 35. That's going to do it. 7 divides by 35 because I counted by 7s to get there. Because it ends in 5, it will also divide by 5. So I've got what I need. 35 is my LCD. 35 divided by the old 7. This guy needs 5s. To create 10, to go over the 35, that must be its denominator. Now we reload for the next one. 35 divided by 5. This guy needs 7s to get his job done. Definitely going to have 35 in the denominator, but 3 times 7 puts us at 21 right here. So we got the 7 already done. And now 10 and 21 makes 31 over 35. And I haven't been running into this problem yet at the end. So we've got 7 with 31 over 35. 31 over 35 doesn't reduce, and I'm good with the 7 and that fraction hanging out behind. As we turn the page, we get into some of the more challenging stuff. All right, we got 2 and 5 sixths plus 7 and 3 eighths. So what do we have? We got 2 and we got 5 sixths. Back here we've got the 7 and here we've got the 3 eighths. 2 and 7 make 9. Whole number, done for now. And let's deal with those fractions. 6 and 8. 8 is bigger. 8 divided by 6, no. 16 divided by 6, no. 24 divided by 6, yes. 24, bottom of each fraction. That is my LCD, my lowest common multiple of denominators. It's not 48. It's not the first time anyone showed it to us. When a teacher who maybe really doesn't know math says, well, you can just, you heard the word, multiply them together, see 48 is going to work, and then your numbers are definitely going to get bigger sometimes than they need to, which creates more large numbers that they'll hide from you the ability to reduce and make the problem take much longer. Find the 24 and you're in much better shape. So 24 divided by 6, this guy needs a 4 to make 24 and creates a 20 on top. 20 over 24. 24 divided by 8 means I need a 3 to get to 24. 3 times 3 gets me a 9 on top. So look at what happens. We thought we had 9 as our integer. And for a little while we do. But what we have here is 9, and then 20 plus 9 puts me at 29 over 24. We can't keep it that way. That's not a final answer. 29 over 24 reduces. This is 9 plus 29 over 24, so that's 9 plus, and we take our 29 and we divide by 24, where there's a full 1 in there. We bring the 24 here, subtract, we have 5 left over out of the next 24. So this becomes 1 plus 5 over 24. 9 and 1 have always added up to 10, and we have 10 with 5 over 24. You can watch it again, you can slow it down, you can replay it, you can do what you want, but what happened was when I created 9 over 24, I knew I couldn't keep it. So I had to convert that to 1 and 5 24ths, and then the 9 and 1 got together. Those are things that we would later call like terms when we do our algebra. We've got whole numbers 9 and 1 add together to make 10 with the whole numbers, and we have a 5 over 24 off by itself as the only part dealing with the remainder of what we're going to have here for our fractions. So I'm going to keep the rules up there. I'm going to keep that last one there. You may need a little more time. Of course, you can stop the tape, you can roll it back and so forth, but I'll leave it there for a little while, just as I would in class. Because you might want to see it when we do the next one. and it would be right there on the board for us to work with. 5 2/3 minus 3 1/4. Make the 3 a little bigger. Okay. Now what do we have here? We have 5 plus 2/3 plus -3 plus -1/4. See, the -3 and 1/4 are both negative. So when I rewrite this, I'm going to sound like I'm being redundant. When I rewrite this again, I'll have my 5 plus -3 for my integers, and I'll have my 2/3, which is positive, and my -1/4. 5 plus -3 is going to get me 2. Plus, back here, I still have my 2/3 plus my -1/4. So my 2 is parked here for now, and let's see what happens. 3 and 4. 4 is bigger. 4 divided by 3? No. 4 more is 8. Does 8 divide by 3? No. 4 more gets me 12, and that's where I gotta be. So I'm gonna have plus over 12 for a positive, and plus a negative number over 12 for a negative, and here we go. The negative is where it's gotta be, so I can go with positive numbers. When I go 12 divided by the old 3 means I need a 4 to make 12, and I need a 4 to keep us balanced when we make 8 over 12. 8 over 12 is the old 2/3. It's got a 12 in the denominator. 12 that I need divided by the 4 that I had, that needs a 3. Triple the 4 to get the 12 you must have. Triple the 1. 1 times 3 gets me a 3 right here. Now you can't forget the 2, you can't drop the 2. The 2 is here as part of what we're working on. 2 plus, got 8 minus 3, which is 5 over 12. That's 2 and 5/12. So on that one, we didn't run into the case where we had too big of a fraction with an improper fraction, or we didn't have enough to borrow from, we didn't have enough to subtract with, so we were okay there. Subtraction just seems a little harder than addition for many people, and that's okay. But all we have to do is go and get what we need from what we have, right? We're not borrowing from a bank or a loan shark or anything like that. We're taking our own stuff and using it in a different way to get these answers. So let's take 9 2/3 minus 3 5/6. Now what I like to do is turn into a positive 9 plus a positive 2/3 plus a -3 plus a -5/6, which will then get me 9 plus -3 for my integers plus a 2/3 plus a -5/6 where my fractions are. 9 plus -3, 9 minus 3 will get me 6 plus. Now I'm looking at these guys, 3 and 6. 6 is bigger. Does 6 divide by 3? Good news, yes. 6 is good. So I'm going to need a 6 to be each of my denominators. That second of my fractions is negative, so I put my negative up here. And off we go. 6 that I need divided by the 3 that I had. I need a 2 here. Not there. Put it in the wrong spot. 6 divided by 3 needs a 2 here and 2 there. Doubling the 3 to get the 6. Doubling my 2 to get myself the 4 that I need. Deal with ones. It's fine. Alright, I need a 6. Divide by 6. This gets a 1. It's going to leave, 6 times 1 makes myself stay at 6. -5 times 1 gets me the -5. So that's not any different so far than what we've done in the previous example. But now we take our 6 and we go plus 4 minus 5. 4 plus -5 gets me a -1. It's still over 6, but it's -1. And you can't do 6 plus -1/6. What to do? Well, what we do is we turn this into the 6 into 5 plus 1, and still got the plus -1/6. How did that happen? What's going on? How do we borrow 1? We borrowed 1 from 5, but I want you to see how it happened. I'm going to take the green. I'm just going to change the color of what's there. Where we had the positive 6 as our whole number, I'll write it green. And where we look at the 6, I'm about to borrow a 1, so let's make sure that we see that the 6 came from 5 plus 1. All right, so that's where we are. We borrowed a 1 because we didn't have enough to handle what's going on with the fractions the way it stood. Okay, now start viewing it as 5 plus The 1 I'm going to put is 1 over 1, plus I have negative 1 over 6. 5 is done. It's going to have a 5 as part of our answer. But what we now have is 6's in both denominators. The 6 we need, divide by the old 1 that we had, we've got to multiply this by 6. So I'm not going to say, oh, just borrow what you got from the thing and make it one smaller. No, absolutely. We take 1 off the 6, it makes 5. The 1 is still visible as 6 over 6. And now, this 6 divided by that 6 means we got 1 to keep it the same. And therefore here we've got negative 1. I told you the 5 would be there till the end now. Right? We've done the borrowing that we needed to. The 5 is here. Denominator is 6. 6 plus negative 1. 6 minus 1 is 5. We get 5 and 5, 6. Do you want to tell me, email me, connect with me in our weekly meeting that there are other ways to do it? I totally believe that. I know it. But sticking with stuff that we knew and writing every step, you might not need to write every one of them. When we got here, we had negative 1/6 as our fraction. I had to break up the 6 to 5 and 1 so the 1 could go in and mix it up with the negative 1/6. Make the 1 right into 1 over 1. It'll always be 1 over 1 for a little while, and then get it after that fraction. Because that fraction is going to take from the 1 something that makes a new fraction, such as our 5, 6 here. But the 5 that we created, when we broke 1 off of it, still standing, is the integer part of our solution. That's what I mean. This is what some people find the hardest part. I want to write every step because I'm not there to answer your questions, but I want to write every step so you can see it, replay it, slow it down, and ask me if you need to when we get together. You want to see it again? Ready? 95 and 3/7. So I can hear the groans even though you won't be watching this for a little while, and you're miles from where I am in all likelihood. Minus 46 and 4/5. I had your chance to watch what happened there. I don't want it here cluttering up what we're going to be working on. I'm going to take it down. It is right. It's in the recording, and you can see it there. Here we go. Ready? What I do first, I got 95 that's positive, plus 3/7 that's positive, plus a negative 46, plus a negative 4 over 5. Then we go and change the order, so we have the 95 plus the negative 46 out in front dealing as integers, plus we got 3 over 7, plus we have negative 4 over 5. Okay, 95 minus 46, let's go, no calculator. All right, you may know that that's going to become 15. I do know that the 90 becomes 80 and 10. But instead of having 90 and 5, I have 80 and 15. If you know 15 minus 6 is 9, you're good. But if you don't, let's complete the 10. Okay, what we want to do is 4 more here, makes that into 10. 4 more here makes that 19. I can do 9 minus 0. We got the 9. 15 minus 6 is 9. I don't have 15 fingers, but make that 4 bigger, make that 4 bigger, and do 19 minus 10. Don't have to worry about the ones. 9 minus 0, there you are. Or you know it, but you got to get a 9 there without 15 fingers. And don't take your shoe off and count on your toes. 8 minus 4 here is nice to get me 49. So all that stuff gets me 49. Plus, I still got my 3 over 7, plus I have my negative 4 over 5. So, I'll keep my 49 in front, and I will go for my common denominator. 7 is biggest. 7, 14, 21, 28. None of those divide by 5. 35 does, and that's where I'm going to land. 35. Divide by the old 7. This needs 5s to get there. 5 times 7 will make the 35. The new 5 that I just made has to turn my old 3 into 15. 15 over 35 is the same as 3 over 7, but it's ready to work with 35 as its denominator. 35 divided by 5 is going to get me 7, so I need 2 7s here and here. 5 times 7 gets me the needed 35. 4 times 7 keeps the balance with 28. So you're going to get another chance here to work on it. You can stop the tape if you want to go ahead and try and finish this yourself. You play it slowly, try it again. There's also going to be stuff like this on the homework. But what are we looking at? We got 49 plus over 35. We got this thing. I got 15 minus 28. We subtract because they don't work together. We get 13. So we got 13 The stronger of the two numbers is the negative, so that's going to turn out to be that. I have a negative fraction on the end. I got to borrow from my 49. 49 will give me exactly 1, plus I've still got the negative 13 over 35. 48 is going to be there at the end. But I've got 1 over 1. It's negative 13 over 35. Now it's nice, that's a 1. It's going to be pretty easy. I don't want to embarrass you by saying, how could you not see that? But if that's a 1, that's my LCD. So I'm going to go with my 48 still here, full number, plus I have each of these is going to be over 35, even better, right? 35 here also. Dealing with 1 means not having to do a lot of computation. You do have to look at what's happening and let it happen, but 35 divided by 1, I need 35 there and 35 there. 35 divided by 35 gets me 1, that's why that stays the same. Here's what will happen. Don't try to memorize what will happen because it won't stay with you. But recognize that I need 35 in both denominators. 1 times 35 will create the 35 for me. 13 times 1 will get me the 13 that's negative. I told you 48 would be there. It is. 35 minus 13. Okay, no borrowing there. 2 and 2. Both positive, right? It's going to be positive because the 35 will definitely be bigger in size than the 13. 35, the small number is 22. I try to divide by 1. I try to divide by 22, 11, 2. None of them divide into 35. And that is our answer. That's really tough. You can watch it a bunch of times. But the concept was dealing with the integers by themselves and the fractions by themselves until we have a single fraction. If the fraction's improper, reduce it to a mixed number and push the 1 out to join the integer. If the fraction's negative, we gotta pull 1, only 1, off the integer to create something to work with for the subtraction of fractions, because it's the fraction part that gives people the most difficulty. So that's the end of 4A, adding and subtracting fractions. The homework can be tough. You might want to do the problems multiple times because it lets you retry them, especially if you're learning this successfully for the first time. But being able to add fractions, get the common denominator, keep the denominator, and what do I do if the fraction's too big or the fraction is negative? These are things we can deal with that have given people trouble for centuries.